Okay, in this video we're going to be looking at quadratic equations, and here we're going to be solving quadratic equations by various methods, by factoring, by using the square root property, by completing the square, by using the quadratic formula, and then from that we'll determine the discriminant and the type of solutions that we would have. Alright, so the first thing we're going to look at is how to solve quadratic equations by factoring. So here is the procedure for solving a quadratic equation using the method of factoring. Number one, you'll write the equation in general form, which is going to be ax squared plus bx plus c equaling to 0. What you want to do here is move terms over to the opposite side so that you'll have a 0 on one side of the equation. Then number two, you'll factor the equation completely. Then you'll set each individual factor equal to 0 and then solve each equation from step number 3. So starting with this first example, part A, you're going to solve, which is in this case 4x squared minus 8x equal to 0. Well, first of all, we got two terms here. We need to find a common factor. And already this equation is in general form. We do have a 0 on the right side of this equation. But on the left side, we got two terms. We need to find a common factor that's in 4x squared and 8x. Well, for the 4 and the 8, the greatest number that can go into 4 and 8 would be 4. Now for the x's, they have to be in both. We use the one that has the smallest exponent. In this case, the x to the 1. So 4x will be your common factor. Now to get what's inside the parentheses, we have to take 4x squared, divide that by 4x. That's going to leave me with x minus 8x divided by 4x would be 2. Now you can check to see by using the distributive property. 4x times x will give you x squared. 4x times the minus 2 will give you minus 8x. So here, this will be 4x times x minus 2 equal to 0. And then we set each individual factor to be equal to 0. So this means 4x equal to 0 or x minus 2 equal to 0. And for each equation, we're going to solve for x. So here for the 4x equal to 0, divide by 4, you're going to get x equals 0. Or for the x minus 2 equal to 0, add 2, you're going to get x is equal to 2. So my two solutions are going to be x equals 0 or x equal to 2. Alright, part B. We got 2x squared plus 7x is equal to 4. And we want to solve this by factoring. Well, we need to move the 4 over to where the 2x squared plus 7x is. So in this case, we need to subtract 4 on both sides. This side I'll have 2x squared plus 7x minus 4, and that's going to be equal to 0. Now this we can factor into two binomials here. So I'm going to break 2x squared up as 2x and x. Now I need to find factors of negative 4. That's going to give me 7x as a middle term. And I'm going to try 4 and 1. But I have to decide where I'm going to put the 4 and the 1. And one has to be negative, the other one has to be positive. Well, the middle term is positive, so I'm going to do this. Put the 4 with the plus sign. And then the 1 will be negative 1, will be minus 1. Now if you check, 8x minus 1x will give me 7x. So in this case here I got 2x minus 1 times x plus 4 equaling to 0. And then we set each binomial factor to be equal to 0. So this means 2x minus 1 equals 0 or x plus 4. Equals 0. And then for each equation, I'm going to solve for x. So for the 2x minus 1 equals 0, that'll be 2x is equal to 1. divide both sides by 2, x is equal to 1/2. And then for the x plus 4 equals 0, now if I subtract 4, you're going to get x is equal to -4. So my two solutions for this quadratic equation will be 1/2 and -4. Alright, suppose you had an equation like this one, 2x times the quantity x minus 3 equaling to 5x squared minus 7x. Well, the left side we need to use the distributive property first. So here if I do 2x times x, that'll be 2x squared, and then 2x times that minus 3 will be minus 6x. And then that's equal to 5x squared minus 7x. So now I need to move some terms over to the opposite side so that I will get a 0 on the other side. So I need to move the 2x squared minus 6x over to this side. Here I'm going to subtract 2x squared on both sides. Then minus 6x, I'm going to add 6x to both sides. So I'm going to have a 0 on this side. Now if I do 5x minus 2x, that's going to give me 3x squared. 5x squared minus 2x squared, that's 3x squared. Minus 7x plus 6 will be a minus x. So I got 3x squared minus x equal to 0. Now here I only got two terms here, which means I need to pull out a common factor that's in 3x squared and x. In this case, it's only going to be x. Okay, because it's in both terms, so we use the one with the smallest exponent. So x will be a common factor. And then to get the other, we do 3x squared divided by x will be 3x. Minus x divided by itself is 1. So I get x times 3x minus 1 equal to 0. And then we set each factor equal to 0. So x times 3x minus 1 equaling to 0 means x is equal to 0, or 3x minus 1 equals 0. Just continuing this on this side. Well, x equals 0 is solved for x, but for the 3x minus 1 equal to 0, if I add 1, I'll have 3x is equal to 1, divide by 3, x equal 1/3. So here's 0 and 1/3 are my two solutions to that quadratic equation. Okay. Alright, now let's look at the next method of solving a quadratic equation, and that's by using the square root property. The first thing we do here is write the equation in the form u squared is equal to d. And then take the square root of both sides of the equation, isolating u on one side and obtaining plus or minus d. And then there should be two solutions. U is equal to the square root of d and u is equal to negative square root of d, unless d is equal to 0. So let's look at example number 2, parts A, B, C, and C. Here we got 3x squared minus 15 is equal to 0. The first thing we want to do here is get that x squared by itself. I'm subtracting 15, so I need to add 15 to both sides. So here I'm going to have 3x squared is equal to 15. And to get the x squared by itself, we'll divide by 3 on both sides. So we get x squared is equal to 5. But here I want to solve for x. X is being squared, so the opposite of squaring something will be to take the square root. And keep in mind, when you take the square root, you have to bring in that plus or minus symbol. So the square root of x squared will be x. That's equal to plus or minus. Now 5 is not a perfect square, so I can't take the square root of 5 and get a whole number from it. So it just be x is equal to plus or minus the square root of 5. Now, of course, in the homework, they're going to ask for both answers entered separately, like this. And that's simply because there is no plus or minus symbol. So you have to enter it as x equals square root of 5 and x equal negative square root of 5. Okay, now part B. X minus 2 quantity squared is equal to 12. And we're going to solve this using the square root property. Well, first of all, I see a square in front. Because you have to think of this. You're taking x, subtracting 2 from it, and then you're going to square it to get 12. Well, here we're going to do the reverse. We have to do the opposite of squaring first, which would be to take its square root. And when we take the square root on both sides, you want to bring in that plus or minus symbol. So the square root of x minus 2, quantity squared, will be x minus 2, because the square root and the square are inverses. Now the square root of 12 is not a perfect square, but it does have a perfect square in it. So we need to find the largest perfect square that can go into 12, which is in this case 4. Because 4 is a perfect square, it goes into 12 3 times. Because I have to write 12 as 2 factors. One of them has a perfect square in it. So I'm going to bring down the x minus 2. That's equal to plus or minus. The square root of 4 is 2. Square root of 3. So I got x minus 2 is equal to plus or minus 2 square root of 3. Now I'm going to rewrite this over here, because I know I'm going to have to solve for x. I'm subtracting 2, so I need to add 2 on both sides. So here I'm going to have x is equal to 2 plus or minus 2 square root of 3. Now again, it doesn't have the plus or minus symbol in it, so that means we need to write that as 2 separate answers. As 2 plus 2 square root of 3, and the other one is 2 minus 2 square root of 3. Okay. And part C, 9x squared plus 25 equaling to 0. And we want to use the square root property to solve this equation. Well, here we got to get the x squared by itself. We're adding 25. So we need to subtract 25 on both sides. So we get 9x squared is equal to negative 25. And then to get the x squared by itself, we divide both sides by 9. That's going to give us x squared is equal to, we'll leave this as negative 25 over 9. But again, we're squaring the x, so we need to solve for x. To do that, the opposite of squaring something will be to take the square root on both sides. And again, we bring in plus or minus. And keep in mind, the negative 25 over 9 is all underneath that radical. So the square root of x squared would be x, and then that's equal to plus or minus. Let's see. The square root of 25 is 5, over the square root of 9 is 3, but we got a negative sign. That means negative 1 is involved in it. The square root of a negative 1 is I. So we got x equal plus or minus 5/3 I. Now again, we have to write this as 2 separate answers. Like this. 5/3 I and negative 5/3 I. Okay, so that's how we solve quadratic equations by using the square root property. Alright, next we'll look at quadratic equations by completing the square. So here we're going to look at how we can complete the square. If you're given a binomial, x squared plus bx, we can complete the square by adding b over 2, and that quotient will be squared, where you're going to get the result as x squared plus b times x plus b over 2 squared, which will factor out as x plus b over 2 quantity squared. In other words, you're going to take 1/2 the coefficient of your x term, and then you're going to square it. Okay? And then you'll add that to your binomial. And then you'll factor it like this. X plus 1/2 the coefficient of x, and that quantity will be squared. Here's a couple of examples of just that. Here we want to complete the square for each binomial, x squared plus x squared minus 8x. So here we want to find out what term we're going to need to add to x squared minus 8x. And then we're going to factor that into this form right here. Alright, in this case here, we take 1/2 the coefficient of x. So here, 1/2 of 8 will give us 4. And then we're going to square that 4. 1/2 the coefficient of x, and we square it. So the b is the 4, that's the coefficient of x. 4 over 2 will give us, 8 over 2 will give us the 4, and then you square it, you'll get 16. So for this x squared minus 8x, we're going to add to it 16. Now that x squared minus 8x plus 16 is a perfect square trinomial, which we can factor as this. We know we're going to have an x, and then the middle term is a minus, so the minus sign has to be here. Whatever this middle term here that you have, that sign has to be the same here. And then 8 divided by 2, 1/2 of 2, 1/2 of 8 would be 4. So the x minus 4 quantity square. Now you could do this. This has to be negative, this has to be negative. The factors of 16 giving you 8 will have to be 4 and 4. X minus 4 times x minus 4 is the same as x minus 4 quantity square. Alright, part B. 1/2 x squared plus 1/2 x. Okay, so now we need 1/2 of the coefficient of x, which is again 1/2, and then that's going to be squared. That's going to give us the third term for our trinomial. 1/2 times 1/2, that's going to be 1/4. Square that 1/4, you're going to get 1 over 16. So that x squared plus 1/2 x, we're going to add to it the 1 over 16. And now we can factor that as it's a perfect square trinomial. We can factor this as this. The x squared, of course, that's going to be x. 1/2 of the coefficient of x. So 1/2 of 1/2, that's this 1/4 right here. That 1/4 will go here. The middle term is a plus, so there must be a plus sign in between those two terms here. So x squared plus 1/2 x plus 1/16 will factor as x plus 1/4 quantity square. Okay. Alright, next we'll look at how to solve a quadratic equation by using that concept of completing the square. Okay, so when a quadratic equation is not factorable, then one method is to solve by completing the square. And here's the procedure for that. If there is a coefficient for the x squared term, such as ax squared, you want to divide the equation by that coefficient, which is a. And then number 2, rewrite the equation so that x squared plus bx is equal to c. Sometimes you may have to move the constant over to the other side in order to get just the x squared and the bx by itself. And then that's where you take half the coefficient of x and square it. And then you'll add that to both sides of the equation. And then you'll factor that into a perfect square, which will be a perfect square trinomial. You'll factor it into this form right here on one side and combine like terms on the other side, which are your constants. And then you'll solve the equation using the square root property. So in this particular problem here, we got x squared minus 6x plus 4 equal to 0. So here we're going to complete the square on this one. What I'm going to do first is move that constant over to the other side. Okay? So I have x squared minus 6x. And if I move the plus 4 over to the other side, it's going to be a minus 4. So I got x squared minus 6x equal negative 4. The left side, I'll complete the square. Now up to the side, you can do this. 1/2 the coefficient of x, which is negative 6, and then that's going to be squared. Take 1/2 of negative 6, you're going to get negative 3. And then you have to square negative 3. Negative 3 times negative 3 would be 9. So that 9 is what's going to be added to the left side of this equation. And if I'm going to add 9 to the left side of this equation, where that negative 4 is, I also have to add 9. Again, what I do on one side of the equation, I must do on the other side. Now I'm going to factor that x squared minus 6x plus 9, because that is a perfect square trinomial, which will be the square of the binomial here. So the x squared will be like x. The term here for the other one, if I take half of 6, that's going to be 3. Whatever the sign here is for the middle term will be the sign inside the parentheses. It's a minus sign, so it has to be a minus sign in between the two terms. So that's x minus 3 quantity squared for x squared minus 6x plus 9. Then that's going to be equal to negative 4 plus 9, which is 5. Now I can solve this using the square root property, because this is squared. The opposite of squaring something will be to take the square root. And I need to bring in plus or minus as well. So the square root of x minus 3, and we square it, will be x minus 3. That's equal to plus or minus the square root of 5. And then to solve for x, we just add 3 on both sides. So I'm going to have x is equal to, now these are two totally different terms, I can't combine those, so I have to write this as 3 plus or minus the square root of 5. And of course in the homework, you have to enter it like this as two separate answers. 3 plus square root of 5, 3 minus square root of 5. Okay. Part B. Now this one has a coefficient in front of the x squared other than 1. We got 9x squared minus 6x minus 4 equal to 0. Okay, so the first thing I need to do here is divide each term by the coefficient of my x squared term, which is the 9. So that's what I'm going to do here. Divide each and every term by 9. That's a 9 here. Let me make that clear. So here 9x squared divided by 9 will be x squared minus 6 divided by 9, that's 6 over 9. I can reduce that to 2/3. So that's 2/3 x minus 4 over 9 equals 0. Now I'm going to move that minus 4/9 over to the other side. So I'm going to have x squared minus 2/3 x equals 4/9. Because on the left side, I'm going to complete the square. Okay? So when I complete the square, I'm going to do this. I'm going to take 1/2, the coefficient of my x term, which is 2/3, and then that's going to be squared. Now, if I take 1/2 of 2/3, well, these 2's divide out, I'm going to be left with 1/3. Square the 1/3, you'll get 1/9. So that 1/9 is what I'm going to add to both sides of this equation here. So I'm going to have the x squared minus 2/3 x. I'm going to add 1/9 to the left side. And I'm also going to add to the 4/9 the same 1/9. I have to add the same term to both sides of this equation. The left side is going to be factored because it is a perfect square trinomial. I can factor that out as a binomial square, so it'll be an x here. If I take 1/2 of a negative 2/3, that gave me this 1/3 right here. That 1/3 goes here. And the sign of the middle term is a minus, so it must be a minus sign in between the two terms in the binomial. So the x minus 1/3 quantity squared, and then that's going to be equal to 4/9 plus 1/9. That'll give me 5/9. So we got x minus 1/3 quantity squared is equal to 5/9. I'm going to continue this here. Since I'm squaring something, I can use the square root property by taking the square root on both sides. So I have the square root of x minus 1/3 quantity square equal, and I have to bring in plus or minus since I'm taking the square root on both sides. Square root of 5/9. Now the square root of x minus 1/3 quantity squared will be x minus 1/3 equal plus or minus. I can't take the square root of 5, so I need to leave that 5 underneath the radical. But I can take the square root of 9. That's going to be 3. So I got x minus 1/3 equaling to plus or minus square root of 5 over 3. And now to solve for x, I need to add 1/3 to both sides. So I'm going to have x is equal to. Now this I can write as 1/3 plus or minus the square root of 5 over 3. And in this case here, the denominators are the same, so I can write all of this as 1 plus or minus square root of 5 over 3. Now, my two answers here will be 1 plus radical 5 over 3, and my other answer will be 1 minus square root of 5 over 3. That's the answer you'll have to enter in as in your homework. Okay. So this is how we can complete the square to solve a quadratic equation. Fortunately, there is another way of solving a quadratic equation, and that's by using the quadratic formula. So here, solving a quadratic equation using the quadratic formula is a method that always works for solving quadratic equations. And with those two examples that we did, we could use that quadratic equation. So the solutions of a quadratic equation can be found by the formula x equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. But only if the equation is written in general form. That means it has to be written as ax squared plus bx plus c equaling to 0, where a is not equal to 0. Okay? So in this example, we're going to solve using the quadratic formula. We got 2x squared plus 2x minus 1 equal to 0. Now in this case here, we need to identify three things. We need to identify a, and b, and c. When it's in general form, we can identify those three constants. Your a is the coefficient of your x squared term. That's going to be 2. The b is the coefficient of x. That's also 2. The c is your constant, -1. So here we can substitute a, b, and c in that quadratic formula, which is of course x equal -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So here b is 2, so that's going to be -2 because of the negative sign in front, plus or minus the square root of b is 2 squared minus 4 times a, which is 2, times c, which is -1. All that's divided by 2 times a, which is going to be 2 times 2. And I'm going to have to continue this on over here because I'm running out of space. Here, bring over the -2, plus or minus the square root of 2 squared will be 4. Minus 4 times the 2 is a -8 times that -1 will be a +8. All over 2 times 2, which is 4. Now underneath the radical, if I add 4 plus 8, I'm going to get 12. So I have x is equal to -2 plus or minus the square root of 12 all over 4. Now 12 is not a perfect square, but 12 does have a perfect square in it. The largest perfect square for that would be 4. So I have -2 plus or minus the square root of 12. I'm going to write that as 4 times 3 because 4 is a perfect square. And all of this will be over 2. So we get -2 plus or minus. Square root of 4 would be, and this should be over 4, I'm sorry. Square root of 4 would be 2. And then the 3 will remain underneath the radical. So I get -2 plus or minus 2 square root of 3 over 4. Now, as you notice in the numerator, the common factor there is a 2. So I'm going to go ahead and pull out the 2. Let me first write x equal first, and then pull out that 2. Factor out the 2. Now here, this 2 into -2, or -2 divided by 2, will be -1, plus or minus 2 square root of 3 divided by that 2 will be square root of 3, all over 4. And then divide 2 with that 4, I'll have a 2 in the denominator. This will be a 1 up here. So I'm having x is equal to -1 plus or minus the square root of 3 all over 2. Now, of course, since they don't have the plus or minus symbol, we have to write that as two separate answers, or enter this as two separate answers. -1 plus square root of 3 over 2, -1 minus square root of 3 over 2. Okay. So that's how we apply that quadratic formula to find our solutions to this quadratic equation, 2x squared plus 2x minus 1 equaling to 0. Okay. I think there's another example of this. Using the quadratic formula, we got 3x squared minus 2x plus 5 equaling to 0. Okay. Now I need to identify the a, b, and c. Since I do have a 0 on one side, it's in general form. So in this case here, the a is the coefficient of your x squared, that's 3. For x, -2 will be b, and for c, it'll be 5. That's your constant. And then we use our quadratic formula, x equal -b plus or minus the square root of b squared minus 4ac all over 2 times a. And then we substitute the a, b, and the c in that quadratic formula. Now b is -2, but we do have a negative sign in front of the b, so this will be negative of a -2 plus or minus the square root of b is -2, and that's square, minus 4 times a, which is 3, times c, which is 5, all over 2 times a, or 2 times 3. Now, if we simplify this, negative of a -2 will be 2, plus or minus the square root of. -2 when we square it will be 4. Minus 4 times 3 will be a -12, times the -5 will be a -60. All over 2 times 3 will be 6. Okay, and then 4 minus 60 will be -56. So we have x is equal to 2 plus or minus the square root of -56 all over 6. And then, since I got a negative sign underneath the radical, I know there's an I involved in it, so I'll pull out the I. Square root of 56 over 6. Now I think there is a perfect square in 56. So the largest perfect square that can go into 56 will have to be 4. And I know 4 goes into 56 14 times. And then again, that'll be over 6. Square root of 4 is going to be 2. So I got x is equal to 2 plus or minus 2i square root of 14 over 6. And now, in the numerator, I can factor out a 2. As you can see here, I got 2 plus or minus 2i radical 14. That common factor is a 2. I can pull that out. So 2 divided by 2 will be 1 plus or minus 2i square root of 14 divided by 2 will be I square root of 14 over 6. Now here I can divide out the 2 and the 6. 2 goes into itself 1 time. 2 goes into 6 3 times. So this will end up being x equal 1 plus or minus I square root of 14 over 3. And of course, we have to enter this as 2 separate answers here, as 1 plus I square root of 14 over 3, and 1 minus I square root of 14 over 3. By the way, that's the square root symbol. So that's how we use the quadratic formula to solve quadratic equations here. Alright, the last thing in that section is discriminants. Okay, the discriminant of a quadratic equation, ax squared plus bx plus c equal to 0, is this expression right here, b squared minus 4ac. The discriminant is found inside the square root of the quadratic formula. And what the discriminant does, it tells us the number and nature of the roots of the quadratic. So if the discriminant is positive, you're going to have 2 real roots. And this is what the graph will look like here. That means that this graph will have 2 x-intercepts here. One here and one here. If your discriminant is 0, you're only going to have one real root, or sometimes they call it a double root. So you have two x-intercepts, but they're both going to be the same. Or if it's negative, you're going to have two imaginary roots or no real numbers, no real roots. That means that this graph would not intersect the x-axis at all. So let's look at this example here. 2x squared minus 3x plus 7 equal to 0. So here we want to determine the discriminant and the type of solutions we're going to have. So this is where we use that b squared minus 4ac. But in this case, I need to identify what a, b, and c are going to be. It's in general form, so we can identify a, b, and c. The a is the coefficient of your x squared term, that's 2. The b is the coefficient of x, that's negative 3. The c is your constant, that's going to be 7. So we're going to substitute that in this b squared minus 4ac, which is your discriminant expression. So here b is negative 3, and that's going to be squared, minus 4 times a is 2, c is 7. Now in this case here, negative 3 and you square it will be 9. Minus 4 times 2, that's going to be 8. 8 times 7 would be 56. Now if I do 9 minus 56, that's going to give me a negative 47. Now here, it is a negative. My discriminant is negative 47. It is negative. So that tells me I have two imaginary roots. Or, in this case, no real roots. That means that the graph of that quadratic equation will not cross the x-axis anywhere. Okay, here's another example. Here we got x squared plus 5x plus 4 equal to 0. And we want to find the determinant and the type of solutions we're going to have here. So let's identify a, b, and c. Your a is the coefficient of your x squared term. That's 1. The b is the coefficient of x. That'd be 5. But c is your constant. That's going to be 4. So now we use that b squared minus 4ac. Your b is going to be 5, so that'll be 5 squared minus 4 times a, which is 1, times c, which is 4. Simplify that. 5 squared will be 25, minus 4 times 1 will be 4, times this 4 would be 16. And then 25 minus 16 will end up being 9. Now here, 9 is a positive number. Your discriminant is 9. It is positive. So that tells me I'm going to have two real roots. That means that this graph, if I was to graph that, it would cross the x-axis at two different points. So that would be two real roots. And finally, x squared minus 6x minus 1 is equal to 0. And I want to find out what its determinant is and the type of solutions we're going to have. So a is the coefficient of your x squared term, that's 1. The b is the coefficient of x, that's 6. The c is the constant, negative 1. I should say b is negative 6. So here, we use b squared minus 4ac. b is negative 6, so we got negative 6, and that's squared, minus 4 times a, which is 1, times c, which is negative 1. Okay. Negative 6 and you square it would be 36, positive 36. Minus 4 times 1 would be minus 4, times that minus 1 would be a plus 4. 36 plus 4 would give you 40. And 40 is a positive number. The discriminant is positive, so again we're going to have 2 real roots for this quadratic equation. 2 real roots. Okay, so that will complete this particular video on quadratic equations and the methods of solving quadratic equations.